Good evening, everybody. This is Mr. Lowe with today's lesson on probability and tree diagrams. So for today's lesson we are going to be talking about these two things and how they are used to calculate lots of different things. Let's start out with factor trees. That's a good review. We've done factor trees. Hang on one second. There we go. We've done factor trees for several days, and we're going to start with understanding what a factor tree is. All we're doing is we're using factor trees. You guys might remember how to do this. You take 36, and I need to come up with two factors, or two numbers I can multiply together that equal 36. And there's a couple of different ways. We can do, let's see, 2 goes into 36 18 times. So we can use 2 and 18. Or we can use 6 times 6, because that is also 36. We'll do that one. 6 and 6. And it's not 6 plus 6. I'm seeing that mistake being made a lot. Factor trees, factor being the key word there, the number you multiplied together to get 36. So I'm taking 6 times 6, that equals 36. I'm asking myself, is 6 a prime number? Is it prime? That's the question that you want to be asking yourself. If it's prime, we're going to circle it. If it's not prime, what we're going to do is continue to break down this factor tree until we can get to all prime numbers. So I'll do 6 times 6 is 36. 6 is not a prime number, but I can break 6 down into 2 times 3. And 2 times 3 equals 6. Both 2 and 3 are prime, so I'm going to circle those. And then obviously over here, it'll be the same thing. It'll be 2 here and 3 here. And we've done this before for several times. We say the prime factorization for 36 equals 2 times 2 times 3 times 3. Or we can shorthand write that and say 2 to the second power, or 2 squared, times 3 to the second power. So this is the prime factorization of the number 36. Now we're going to use this concept of calculating the prime factorization to be able to find what we're going to call the GCF. If you remember, the GCF is the greatest common factor, and the LCM. And the LCM is called the least common multiple. So we're going to do that for both of these examples. Let me just kind of clear my annotations and we'll get started here. So away we go. We are going to start with these two numbers, 18 and 30, and I'm going to go ahead and move those over just a little bit so that I have some more room. Alright, when I'm dealing with 18 and 30, I want to calculate the prime factorization of 18. So I'm going to say to myself, what times what equals 18? You can do 2 times 9, because 2 times 9 equals 18. You could have also done 3 times 6, because 3 times 6 equals 18. But I start with 2 because 2 is a prime number, so I'm going to circle that. And then over here I have 9, which is 3 times 3. And I know 3 is also a prime number. So the prime factorization for 18 equals 2 times 3 times 3. Or 2 times 3 to the second power. We'll do the same thing for 30. And 30, I'm going to start out a little bit differently. I know, finding numbers, the zeros in the ones place, that's easily multiplied by 10. So I'm doing 3 times 10. 3 is a prime number. 2 times 10 is, or 2 times 10, how about 2 times 5 is 10, and 2 is also a prime number, and so is 5. So the prime factorization for not 13, how about for 30, is 3 times 2 times 5. Now, we can use prime factorization to calculate the greatest common factor, the GCF, in a couple of different ways. What I'll try and do is try and line these numbers up. Let me put those over here. Actually, that's okay. We'll leave those here. And let's get these guys and move them over here. And I kind of put them this way so that we can kind of line them up and see how it all shakes out. And I'm going to use a different color now. And what I want to be doing after I put those two sets of prime factors on top of each other is I want to then circle. Put a circle around the common numbers. So I have, actually, you know what I should have done, you guys? And I'm surprised nobody said this, is I should have taken this one and rewrote it. It should have been 2 times 3 times 5. All I did was just write them in a different order. So now we can take that whole group and move it over here. Alright, so now we're ready to do our circling. When we circle the prime numbers, I want to circle the numbers that are exactly the same in both 18 and 30. So I can see I used my 2, and I can see I used my 3. I have a 3 here, but not an extra 3 down here, and I have a 5 down on 30, but not a 5 in 18. So the greatest common factor of 18 and 30 is going to be 2 times 3, which equals 6. 6 is our greatest common factor, and that's going to be helpful for us in finding other examples when we're trying to calculate common denominators. So we're using greatest common factor. Now I'm going to do the same process now for, maybe we'll do this one in white. We're going to do the same process. We're going to calculate the tree diagram for 18, which we have right there, and the tree diagram for 30, which we have right there. And I'm going to write it over here to calculate, show you how to calculate the least common multiple. So I'm going to go 18 equals 2 times 3 times 3, and we have 30 now equals 2 times 3 times 5. And again, what we want to be doing here is we want to circle the ones that are the same. So it's 2 times 2. So you see the process is exactly the same. Now it gets kind of interesting. After you circled the 2 factors that are the same in each, or the factors, all of the factors that are the same in 18 and in 30, we then want to cross off one of those, because I don't want to use that one and I don't want to use that one. That leaves us with a least common multiple for both 18 and 30 of just the ones that we have left. I'm going to circle those in green so you can kind of see. 2 times 3 times 3 again times 5. And if we do 2 times 3, well, that's 6. 6 times 3 is 18, and 18 times 5 is 90. So the least common multiple, if I were to list all the multiples of 18, saying 18 times 1, 18 times 2, 18 times 3, those are multiples, and I were to list all the multiples of 30, 30 times 1, 30 times 2, 30 times 3, and we keep working those out, 90 will be the lowest common multiple, the least common multiple. Okay, so and this will work. This process will work using tree diagrams, specifically with prime factorization, to calculate greatest common factor and least common multiple. All right, so tomorrow when you guys come into class, you're going to be working first with using tree diagrams to help you, factor trees, to help you calculate greatest common factor and least common multiple. So hopefully you guys are taking notes. Again, I want to remind you, make sure you bring your notes to class so you can kind of review and use those notes again. Alright, so now, once you're done understanding how to calculate greatest common factor, least common multiple, now we can start talking a little bit about probability. And probability is actually really easy. Basically, to understand probability, you need to understand what an outcome is. And an outcome is simply the result of an experiment or a situation that involves uncertainty. So what we do to determine our outcomes is I want to spin this die. And when I spin that die, I get a number 5. If I spin it again, I get a different number this time. And I can spin it one more time, and I get a different number. Each of these numbers, each time, even though the 6 came up twice, each of those numbers is an outcome. The same thing can hold true for flipping a coin. And flipping a coin is really easy. Let's say if I were to flip this coin, well, obviously the outcomes can either be heads or tails. And just to prove it, we would flip that coin, and we get a head or a tail. Let's try it again. And again, we get a head or a tail. Now I can flip both of those at the same time, and they both come up heads. I can flip it again, and now they both come up tails. I can flip it one more time, and they come up heads again. And tails again. Now you might think, man, Mr. Lowe, this is fixed. It's just coming up heads and tails. Well, it is, but it's not really fixed, because it could come up heads or tails. Alright, so understanding what an outcome is the start of this lesson on probability. So, for example, all the possible outcomes that the spinner, this particular spinner, can be are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just each one of those outcomes. Now, if we change that and we say, well, I don't want to know what the outcome is for numbers, what if I was thinking of colors? Well, how many colors are there? There's only two. There's a blue, or I guess you'd call that like a beige. So the probability of landing on blue is going to be a 50-50 chance, because there's an equal number of blue spokes and an equal number of yellow spokes. The probability of landing on any one of these numbers is a 1 in 10 chance. So if I were to spin this, let's see if I can spin it. If I were to spin that, whoops, don't want to do that. There we go. If I were to spin that, and it lands on 2. And then if I spin it again, it should land on something different this time around. It doesn't have to, because it still could land on 2. And now it lands on 4. So each one of these outcomes has a 1, that outcome, over, like if I were to calculate the outcome of it landing on 4, well, the only time 4 shows up is one time out of a total of, there are 10 spaces. So each outcome is a 1 in 10 chance of occurring. So let's try and move forward here. Now, if outcomes are likely or equally likely, that means there's an equal chance of each outcome to occur. This makes the chance of any outcome occurring fair. This is when we talk about fair games. So if we were to run the spinner like this, and I were to say, okay, you guys, I'm going to give you $5 if you spin that spinner and it lands on red. You're going to give me $10 if it lands on green. So do you think that is a fair game? Well, obviously that's not a fair game. We could check that just by dragging this over. No, that is not equally likely to occur. Each of those outcomes, both red and yellow, are likely, but not the green one. What about this spinner right here? Each one looks to be about the same size. Each one covering the same. There's only 3 colors. It is a 1 in 3 chance of occurring. That is an equally likely outcome. Okay? Equally likely outcome. How about this one down in here? This one's a little bit more difficult. Let's take a look at it. What is the probability? There's the bell. What is the probability of any one of these occurring? Well, it's blue 4 times, red 2 times, or yellow. Is that equally likely to occur? No, it is not. Alright, so one more slide. And I'll have to finish this up. There'll be part 2. Bye! I gotta go get the kids. Have a good day.